Am I starting now?
Well, yes, let's go now. Anyone can still ask questions in the clouded chat on some of the previous talks if you want. I know it takes a bit of time to process the talk and come up with a question. So please, Sophia, start, and thank you for being here.
Thank you for inviting me. At this point, I was going to ask you, what do you think the title of my talk means? But given the limitations of my technological ability to do polls on Zoom, I'm going to give you the answer. This is a picture of Sparta. Sparta was one of the cities in ancient Greece, known for its warriors. And apparently, in their festivities, they used to dance. In separate groups, the older guys would dance and say, we have been great in our time. We have made sure that our country has stayed free and built a great country. The men would also dance and say, we are now the ones who look after the country and we're making a great job. And if you like, come and check us out. And the younger ones would say, and we are going to be even best than all of you. We are going to be much better. And I think this is the theme of this workshop. It is about young people and how they're going to be better than what the old ones were. So I was asked to reflect about how things like how should one select the research area, how should they plan their careers. And I must say, I find this a very difficult question. So instead, I'm going to talk about what happened with me in my journey, what worked well, what didn't work well. And I'm going to invite you to think about what might work for you. My journey started at the Technische Universitaet Karlsruhe, which is called now KIT. This is the palace of the Markgraf, and my department was right next to it. It was a very young department at the time. The subject was called informatics. There were 6 professors. One of them was Professor Gerhard Goos, who was my PhD supervisor, and Professor Peter Denker. And I must say, even though it's about 40 years now, I'm still thinking often about things that they taught me and Professor Goos's approach to research and life. The professors did not have any CS training themselves. They were physicists, mathematicians, or they had worked electrical engineers. And 2 years ago, I found out that actually between what they were teaching us and what they knew themselves, there was a gap of about 2 weeks. They were 2 weeks ahead of us. The department was huge. We were together with the maths department, 400 math students and 100 CS students. 40% were women. And our professors used to say, the women will excel in computer science for 2 reasons. Because of their logical thinking, and because also women might want to stay at home, and staying at home and combining computer science will be easy. You might think such arguments about women staying at home are not that good, but at the moment we're also staying at home, so it has gone full circle. What was life like? When we programmed, we used punch cards. You had a stack of punch cards, which you have to move very carefully so that they would not fall apart. And then you would put it into this machine that would read it for you. And then it went to the closed shop, and it would take several hours. And then you would get a big printout that said, syntax errors on line 3. And you could start again. So that was a bit upsetting. We were taught a language called Algol 68, which was at the forefront of the computer science and programming language research at the time. a beautiful language, and people had fallen in love already at that time with type systems, and they were very interested what are equivalent types and what are ref type, const types, val types, and so on. For me, it was a bit confusing, I must say. But we didn't have a compiler for Algol 68, so we were taught in another language that is called Simula, which is actually, I found out 15 years later, it was the foundation of object-oriented programming. And when I read the book on Simula or followed the course, I was a bit confused. There are all these classes. What's the use of all these classes? That's peculiar. So things didn't make much sense for me until I went to the physics department next door, where they were teaching us Fortran. And then things again made sense. So I was a kind of relieved. Still, things like x equals x plus 1, for me, it really didn't make sense. It has taken me months to get to accept that you can even write such a thing. I don't know now why it was so difficult, but it was very difficult. And then we get on to, here is the program that calculates the greatest common divisor. And okay, when I ran a couple of examples, I could see it, I could believe it. And it was also very, very peculiar and unconvincing to me. So I really was losing heart, and I was thinking perhaps I should drop computer science, perhaps I should do chemistry, something else instead. But then came a great moment for me when we were taught Hoare logic. So that ties very well to the earlier talk. Here is the invariant, and it tells me that the greatest common divisor is of the input values is the same as the greatest common divisor of while I'm running the program. And suddenly everything made sense, and it was exciting, and computer science was great, and I decided to stay with it. So I owe this, I think, to Tony Hoare and also to Professor Goss, who taught us Hoare logic. So one lesson is don't give up. A couple of years later, I was in the happy situation I could submit my thesis, and a colleague of mine said, "Oh, well done, Sophia." Thank you, Martin. And then he proposed that I would spend the evening with him and his wife, and they would cook me dinner, and I would explain about my research. And I thought, whoa, you are working in databases. My research is in parser generators. You don't know about parsers. I'm going to discuss with you parsers, parser generators, and what I did on top of it. It doesn't make any sense. But I couldn't quite say that, so I did spend several hours trying to explain, and in the process, I found how to explain what I did to everybody, and it came handy to me when I gave my presentation to my examiners, and then I realized how precious it is to obtain feedback, and that you should take any opportunity to obtain it. A couple of years later, I continued my career at Imperial College. And perhaps the first thing that I learned is combining family life and career is not trivial. I think it is one of the most difficult things for all of us. And I hope actually that it's now easier than it has been for me. I had several very good colleagues, many, and I decided to just mention a few, and you might be recognizing some of these colleagues. I was given the remit to teach a course about a survey of programming languages. That was wonderful. And in the process, I thought, that was actually late 90s. So in the process, I thought one should look at object-oriented programming. There is this language, Smalltalk. I started reading and trying it out, and that was a revelation. That made lots of sense to me. I had been looking at a lot at module systems. There was a language module 2 at the time. But I thought Smalltalk and object-oriented programming made sense. And then I realized later on, I had seen it already in Simula, but I had not recognized it. Sorry, I'm not. So it's wonderful to have the opportunity to go from teaching to research. And one should be open and revise their opinions. About a year later, for about a year, we have been working on, again, on module systems. And the idea was one should unify an interface with a parameterized interface. And we got very excited and spoke with several people about this, and came across the question, where is the model of that? Here is a wonderful story that you are saying in terms of examples, in terms of diagrams, where's the model? So we worked on it, and at some point, Ross had a very succinct way of expressing it, and he said parameterized modules are nothing else than push-outs. And the amazing thing for me was we had been spending hours explaining the ideas, and as soon as this one sentence came, everything was clear. So using the right tools is super important. We then worked on developing an algorithmic version of the system that we had proposed, and we wrote a proof, and then we found an error in a proof, and then a new proof, a new error, more proof, more error. I have spent 5 years. I think the others had given up, but I spent 5 years working on it. I kind of co-discovered issues to do with type system and algorithmic type system and so on, but still, it was wonderful when I finally decided to give up. My life was freed and I could consider new questions. Another research that we did a couple of years later was develop a model for Java. So this is a model for things that were widely used. It was, I think, the first model for Java, and we were not trying to obtain the kind of results that people were looking for at the time. There was no denotational semantics, no category theory, no lambdas, and there was a lot of interest in this work. So in that respect, simple is a good idea. We built on further on that, and we studied overloading and the interplay of inheritance. And in fact, the earlier work on Java was also motivated by some interesting observations on how those two play together. So what worked very well was find where is the surprising feature, where is the thing that makes it more interesting that you do not expect, and study that. Luckily, we published that before Gilad Bracha came along. So Gilad Bracha then joined Sun and was in charge of the language development, and he has been adamant that overloading was undesirable. I thought, why? It's perfectly nice. It gives me shorthands. But Gilad had the very succinct one sentence answer, which is, you should have type erasure. The types are filters that filter out bad programs, but they don't change the behavior of the programs. And that made sense. And then I suddenly realized all this work that we had done about overloading and inheritance was on top of a bad programming language feature. And perhaps if I had known, we had never spent all this time working on overloading and inheritance. So one conclusion is work fast, publish fast, rethink it. Even though you change your mind later on, you have learned so many things by doing the work, by getting the feedback, and then you can move on. I have always been very influenced by work by Luca Cardelli. Unfortunately, he's no longer working as a mainstream in programming languages. And at some discussion, he said, I was wondering at some point what it means for an object to change class. Ooh. But then I convinced myself that this had no meaning. So this has had a profound influence on me. The funny thing is, when I mentioned this to Luca some years later, he says he has no memory of having this discussion. But I was intrigued by this. And when I visited Torino, I proposed that we should be working on this. And indeed, we did some work together with Mariangela Dezzani and Ferruccio Damiani and Paolo Giannini, which was about objects changing classes dynamically. It took us a month to develop what that would mean, the operational semantics, and the type system took us a year. It took us a year to find the idea of the type system, and it took a lot of iterations to find how to tackle that. And this work has led also to, has echoes in the works on type state and concurrency. So this is a work that I particularly like. I think it would never have happened if I didn't have the hardworking Italians on board. So hard work is very important. And I was surprised how indispensable the formal models were. And up until that point, I thought all the ideas are in your head and you make a model in order to convince the others and in order to convey your ideas. But suddenly, the model was what I needed in order to understand myself, what we were doing. Java was, I think, the first programming language to insist on a model of dynamic linking. And this model of dynamic linking had repercussions on the meaning of binary compatibility. It was a big chapter in the book, and they were very proud of all the power that this gave you. But together with our PhD student, David Rugg, we realized first, it doesn't give you everything that it's supposed to give you. And secondly, it's an interesting problem to study. We made a mistake, or I made a mistake. I forgot to send the paper to the conference that we were intending. And instead, we sent it afterwards to LIX, and it got accepted. So that's a case of great luck and great fun. And then we continued the work. Sorry, my slides are not. So then the next question is, have a deep understanding of what dynamic linking and verification means in Java. And I got extremely excited about this work. I thought, this is my best paper ever. This is the best paper in the last 5 years, whatever. Super, super excited and interested in the work, but it got rejected and rejected again. And I couldn't believe it got rejected. And I was angry that it was rejected, and I didn't believe that the reviewers did a good job. I thought perhaps they were envious, were trying awful things. I was really, really shattered. I was very depressed. So here is the delusions of perfection, the delusion that what you do is super important and somebody's there to get you. It's to be avoided. At some point then I realized, I saw that was not such a great paper after all. And we moved on to write a different paper together also with Giovanni Lagorio that was about how dynamic linking works in a family of languages, one of them C# and the other one Java. And that work was much better. Another instance of don't give up. At the time, that was early 2000, there was a debate about the foundations of object-oriented programming. There were people who thought that the foundations were in the object-based or the prototype-based programs, and how dynamic should be the development of the code. So with Christopher Anderson, we proposed that you should start with a prototype language. You should add types to your program, and then you could go from prototype-based to class-based, strongly typed. And in the process, we also considered how can we do type inference for JavaScript. The first work led to gradual types, but we never pursued it because what we saw was a huge aim. We saw that you have got a prototype, you add the prototype-based program, you add the types, you know everything, it works. And instead, it should have gone in small steps, and that's what the gradual program did. So we were a bit impatient, or quite impatient. The other work that was type inference for JavaScript, we thought, we can get funding. We put a grant proposal to Microsoft, and we got rejected, and we were told, no. Microsoft doesn't touch JavaScript. And we gave up. We lost heart too soon. And in the meantime, Microsoft is heavily involved in making in TypeScript, in making JavaScript safe, and all sorts of companies are working on this. But we gave up far too early. Don't do that. We developed a model of Java with wildcards, which was fun. It was the first model of Java with wildcards, and Nicholas Cameron, my PhD student, was very excited about simple models, succinct models, and he decided it was not going to have imperative features, it would not have null pointers, and 10 years later it got discovered that the combination of wildcards and null pointers in Java would make it unsound. So this is a case of simple is not always a good thing to have. A couple of, okay, I'm going to go very fast with that. John Potter visited Imperial College and spoke about flexible alias protection, which is ownership types, and that led to a lot of further work. And I was very glad that I did get to do this work and collaborate with Dave Clark on that. But in the process, I missed a family trip to France, which goes back to everything has got its price. Combining career and family is not always straightforward. You have to decide what you do. The collaboration is growing. I am very happy to have worked with a lot of people on this, and we have got further questions to think about. I have the joy of belonging to the communities there, and I revisited my ideas about types and Algol 68. So I'm going to get now to what lies ahead in the journey for me. I am open, of course. I hope that some surprises will come up. We are working with MSR on Verona, on the types and concurrency model, working on splitting objects through types. But the last thing I would like to be allowed to talk a little bit about is holistic specifications. So holistic specification is, again, a collaboration. And it started with Mark Miller saying, discussing with James Noble about encapsulation features and what new encapsulation features we require. And I came in and said, okay, you are talking about these encapsulation features, but what should these features express? And they were never very clear that what they should express. And then James nailed it. He said, encapsulation features are mechanisms with which we achieve robustness. But we don't know what are the guarantees that we want for robustness. And then we started trying to distill what does robustness mean. And I'm going to get to an example. And for this, I'm going to use a safe. So here is a class safe. It has got field, secret, and treasure. And if you want, it has got a method take that allows you to take the treasure out of the safe if you know the secret. So the classical specification for safe is what I write here as specification A. And it says, if you have SF, which is a safe, and you call the function sf.take with argument S, if the secret is indeed S, then afterwards the treasure will be null. And if it's not S, then afterwards the treasure will be the same as it was before. So it is the case that the safe class satisfies the specification A, and so far things are good. But then I go into that class, I make a second version, safe2, and I add a method which allows me to overwrite the secret with whatever I want. And unfortunately, safe2 also satisfies specification A. So that shows me that specification A is not good enough to talk about robustness, which is what I'm interested in. Safe2 is not robust, doesn't do what I would like, but it satisfies specification A. So I need a different specification. Another specification is specification B. And what it says is the secret of the safe never changes. And indeed, safe1 satisfies specification B, and safe2 doesn't satisfy specification B. So I might think I'm done, but actually I'm not, because here is another third version, safe3. So safe3 also allows me to overwrite the secret in the safe, but it only allows me to do that if I already know the secret. So what I would like is a specification that considers safe3 good and safe2 bad. But safe3 does not satisfy specification B, and that means that the specification B is not a very useful one. So we need to think of a new specification, a new kind of specification, which will allow safe 1 and safe 3 and not safe 2. And this is what we call holistic specifications, because they talk about the whole behavior of the module rather than particular aspects of it. And this is my specification C. And what it says is, for all safes, if I can go from a state where the secret of the safe is a value to another state where the I'm very sorry. I'm going to change that on the fly because I made a mistake and it doesn't make sense otherwise. So if I am in a state where the treasure in the safe has got a certain value to another one where it doesn't have that certain value, then this can only happen if there exists some object O which is external to the safe and had access to the secret. And I'm going to visit that again. Okay, I can't do it. I'll have to talk the correction. So the specification is again repeated. The meaning of the specification talks about time. So what it says is if at time t1, the treasure has got a certain value, and at time t2, the treasure, it shouldn't say secret, it should say sf.treasure. So if the treasure has got a different value, then I know that in the current time, there exists some object that is outside the safe and has access to the secret. And in our work, we have many more examples and many more robustness specifications for those examples. Which brings me back to the beginning, where I said that whole logic and reasoning about programs was what kept me in computer science. And now it is that I hope that we will have a more holistic approach to how we specify and think about data structures, not only pieces of code. So in my journey, various things worked well, like the power of finding things appealing and worth looking at, changing opinions, meeting wonderful people, collaboration. I had lots of luck very often. I worked with models, I think, at the correct level. I applied my approach of trying to make things as simple as possible. And some things did not work that well. The delusions of perfection, they were definitely not good for my peace of mind. Sometimes I gave up too soon. Sometimes I lost heart too soon. Sometimes I went along too simple an avenue. And the price of things, this is something that one should also keep in mind. And of course, as everything in life, nothing is absolute. Giving up is sometimes a good thing. When I gave up trying 5 years to prove the correctness of an algorithm, that was a very good thing. When I gave up on type inference for JavaScript, perhaps that was a less clever thing to have done. So what about you? What about the young people? As I said, I cannot give advice. I can only reflect on what happened for me, what went well and less well, and perhaps some of it will be useful or at least to reflect. But I wish all the young participants to have as much luck as I had and to enjoy it as much as I have enjoyed it. And I'm leaving you with this poem by Cavafy. He was a Greek poet, but here is some of the translation, and there is a very wonderful reading of it by Sean Connery. So if you Google Sean Connery and Ithaca, you will also hear him talk the poem. Thank you very much.
So we are happy to take questions so that people have time, and also I have an excuse to say something. I wanted to mention that I don't think it was a mistake at all to model wildcard without the null, because yes, okay, if you add the null, then the system becomes inconsistent while you had a soundness proof. But it's of course very valuable to know that wildcards, they work well in absence of null pointers. You make it sound like a mistake. It's probably not.
I think it partly, of course, I want to say a story, and I thought it was funny that this would happen to me because I was insisting on imperative features and null, and Nick didn't want to have imperative features, didn't want to have null. But I think a paper that says the Java type system is not sound is much more widely cited than a paper that says, yes, we expected that wildcards would be sound, and for this small model they are sound. No?
If some people want to ask questions, and I hope they do, don't be shy. I think you can just unmute yourself. The feature is allowed. You don't need to make a hand or something like that.
And if you want to ask questions from the Iris talk, I think you should also do it. My talk was not a very technical one, except for, of course, for the holistic specifications, which I was very happy I was able to sneak in.
So can I just ask a question from Sophia? Okay, so it sounds like you've had a wonderful career and you really enjoyed it, Sophia. But let's say you could go back. What would you change? I don't think I would have changed anything very much because everything had some good sides. I think I always think 5 years ago I should have done something different, but if I go 30 years ago, then it's good the way it happened. So this is another thing that I hope when you are as far as I am, you will be feeling about your career. I see.
I
so
would
things
have
may seem bad in the short term, but right.
Put more work into this. There is nothing that I think I should not have put work in. There is lots of things where I think I should have put more work in. But if I had done that, then I would have seen less of my children. So it's
Indeed. I think Philip had a question. Philip?
Yes, hello. I tried to ask it also on Clouder, but I'll do it here. So you mentioned early on that there were like 40% women or something when you started on your studies. And I was curious about how, if that has changed. I'm assuming that it has changed. But I'm curious what you think about how that has affected your research and your career and yeah, that kind of thing.
Yeah, so it's interesting. We were a lot of women undergraduates and we were not that many postgraduates. In my group, there were 20 people and there was another woman and myself, and the other woman decided to marry, and even though she was 6 months from submitting the PhD, she decided not to submit it. And people were angry with her. And at the time, I didn't understand why, but now being a supervisor, I totally understand it. I think we were treated when I started my career, when I was a postgraduate, I think we were treated extremely well. We were considered to be a rarity, pioneers. So, and by the way, I was the first woman in my department to get a PhD. There were about 20 foreigners before me, and I was the first woman, which says something. But I think as postgraduates, we were, they loved having us around, and they gave us special and nice treatment. That's not the standard story that you hear, but that's what it felt like to me.
So I think from my personal experience, not at all just to chime in, there was a time at the beginning, not that Sophia was there at the beginning of computing, of course, but computing wasn't considered a male-only subject. If you look at early computers, the people who just carried out manual computation was predominantly women. And then at some point, something shifted, maybe perhaps in the 90s, and people decided that this is a male-only, very techie subject, and women were, because of maybe the aggressive conditions or whatever, female students started being discouraged applying to STEM subjects, including computing, by which time computing was one of those. And hopefully the tide is shifting again, and we are getting to a time that we are encouraging more and more female students. From my personal experience, where I was an undergraduate at Imperial, the ratio of female to male was 1 to 10. For every female student, there were 10 male students. And even in the last 10 years, things have changed drastically. The ratio is more like 1 to 3 now, which is great news. But it has taken active participation and actively people trying to attract female students, which is invaluable.
Yeah, I don't think that the undergraduates were treating our women students so wonderfully as I'm describing from my own youth. Perhaps we can also hear Susan's opinion on that, since as director of studies and head of the department, she knows a lot.
So I started teaching computing in '76, and it was between 35 and 40% female. And it was exactly the same as mathematics. And at the time, what it was believed was computers coming into the homes and schools put females off it. That was the single thing that happened that actually stopped girls being interested in it. And it went from being techie and sort of male to being boring and word processing without ever going through a phase of being interesting. But it's clear that different countries have very different percentages. Eastern European students coming to Imperial certainly come in at a more favorable ratio than British students do. And Chinese students come in at a more favorable ratio. But there's certainly something that happens in many countries, including Britain, that makes it undesirable, unfortunately. But
I think someone has a hand up. Oh.
Yeah, we had times when it was under 10% female.
Wow.
So.
All right. I'm sorry, I really hate to kind of cut off this conversation here, but let's thank Sophia again. We're kind of moving to the next event, which is we're very tightly scheduled. We're going to try to do short-term mentoring events in this room. So please stick around for that.
Can I ask one last question before we move on?
Okay, sure.
Thank you so much. So I am a 12th grader and I'm going to go to college next year. And I wanted to ask that, this apprehension to not getting into STEM starts at a very young age. Like even now in my class, there are very less girls that want to get into STEM, even at the undergraduate level. So how do you think we can make it more interesting for them? Or how do you think awareness can be raised at a young age as this, or even probably younger, so that girls get into STEM?
So can I answer?
Please.
All the research shows that you actually have to get girls before puberty, right? It's really young that you have that the division happens. And my husband was going into primary schools and teaching programming, and he said, this is today, you know, this is 2 years ago, last year, that the teachers would pick boys to do it, not girls. And he would say, I only do it if it's 50-50, in which case he would have 50% girls, 50% boys. And they did learn, he said, slightly differently, but not worse. They just had slightly different interests. So we have to do something to change primary school or elementary school teachers to stop dividing them at that stage.
Okay, so thanks a lot for that. Let me start the short-term mentoring sessions now.